Alright, just to prove I actually learned something, we're going to go over what we did in my strength material class today. You see we have this little graph here. It's called a shear graph. What it is, basically, we have this thing here. This is basically your bar. It could be an I-bar. Well, not necessarily an I-bar. We'll get to that later. Some sort of bar in construction, whether it be a beam of whatever material. And then we have this top here, which is the load. You see we have 10 kilonewtons per meter pushing down on 6 axis points. Now we also have 2 points on the beam pushing up at 10 kilonewtons and 50 kilonewtons here and here. Now it's a 8 meter long beam, and we have 6 meters long of stress spread out at every meter. So we can do the math and divide that out, but I'm not going to do that really. It's really not the point of what we're doing right here. What we want to do, we want to graph this and visually show the stress points being put onto the beam. So it's going to be really crude, and forgive me, this is like the first time I do this. But we're going to start here, and this is going to be 0, I assume. But we're going to go up 10, because we have 10 pushing up on the beam. And then for 2 meters, there is no force, no added force or no negative force. So we have the straight line going over. And then after this, we have force being applied down on the beam for 4 meters. Constant force being applied down for 4 meters. So, take us down to about there. Now there is math and numbers you can put behind this, but I'm just going to show it really crudely just so you get the general idea of what I'm talking about. But you see here we have 50 kilonewtons pushing up. So if we did the numbers, we take this force minus this force, and it's going to bring us up to here. And then there is more force being put down, and it's going to take you to there. Now this line is your 0 line. There's a technical name for it. I don't know that. That was probably in last week's class. But you're always going to start on that line, and you're always going to end on that line, because through the beam the weight is going to cancel out, or so I assume. Now when I was talking about different types of beams, we go down here, you see, you have your T-beam, and you have your I-beam. Of course, the middle of it is called the web, and the top and bottom are flanges. Now, those are going to determine different things in the way the beam is going to support length. Of course, you have the section of the beam and the length of the flange and the length of the web. They're all going to determine things. So the example that she showed would be here. And it's going to show with the compression and tension that goes onto the beam, whether it be in a positive or in a negative way. So we're going to start with... we're going to go 25 times 10 to the third, and you fill that out, and you're going to get 19.3 MPa with compression. And with the bottom of it, that's what the top compression and bottom compression would be the same thing, 25, 10 cubed. That's going to come out to 35.8, and that'd be tension. And you can fill that out with the rest, but we're not going to do that just for, time's sake right now. So we'll flip this over, and okay, here we have more. This is like new stuff, kind of like week 8 notes. The other side is just pretty much a refresher course from last week, but it shows you have a regular beam that isn't undergoing stress, and then you have a beam that is going under stress, with the top being compressed and the bottom is undergoing tension because it's being stretched out. Now, in this, we see anytime something goes under compression, it obviously gets compressed, and the bottom of the beam going under tension is getting pulled apart. But through this, you have a center line that would be L0. And that line, that's a horrible center line, it's not even on the center. But either way, it goes through both beams. But the beam under tension in positive bending or negative bending is going to show the L0 better. That line we call the neutral axis. And that line won't change length. If we were to measure it here, and if we were to measure it here, it would be the same. Where if we measured the top line and the bottom line, it would be different in a stress-free beam compared to a beam that's undergoing positive or negative stress. And then there's some operations that we can do about it. If I can't remember any offhand, it'd be like, I don't know, something with theta and p and L naught, and they're going to cancel out, and it's going to be like y over p or something. I don't know. And probably throw sigma in there. Yeah, I was kind of sort of paying attention. A lot of this stuff I kind of got, surprisingly, but some of it's a little over my head. I probably, if I would have went to earlier classes, probably could have got it. But yeah, it's really great. They give you these little note sheets here, and you see there's a lot of information on it that all gets sorted out through the entire class. So everything's here that you need to go over in class. You need to keep all these, and you can review them for the test. But unfortunately for me, this test will be online, and since I don't have a student account, I can't go in and take it. So that just proves that I actually did learn something today in my engineering class. Alright, keep reading the blog and keep checking back on YouTube. A little side note, I did say that I wanted to get some video of the monkey and the diving board and the bridge, but I didn't get, the guy sitting in front of me, he leaned over at the time so we couldn't see it, but basically what was going on, they had a bridge made out of like styrofoam or something, and it was taped at the top of it. Kind of similar showing the compression and tension that I was showing you on the paper earlier. And basically what they would have to do, they'd have the girl that went up, like she had her arms out and she's holding the bridge, and because the tape was on the top, the monkey was putting pressure on the top and it fell down, and the same way with the diving board. And really long story short, she's like, no, well, how are we going to do to fix this? And we're like, well, let's flip it over so the tape's on the bottom, that way when the pressure is exerted on top of the beam, it won't collapse because the beam will be supporting it along with the duct tape. So that's it. That's the monkey story. Yeah, I was bummed out. I really wanted to do it. I really wanted to help out, and I thought that would be really pertinent for the documentary, kind of playing an interval role in class. But hey, whatever. Didn't work out. I still got a lot more time here. Hopefully, I can have more opportunities of helping out in class and getting something done.